Hi friends, let us learn one very important result in limits. Limit of theta tends to 0 sine theta by theta. By the look of it, we cannot decide in a straightforward way what exactly is the limit. Because sine theta, when theta tends to 0, this is 0 and theta is also 0. So it is looking like 0 by 0. 0 by 0, do we call it 0? Or do we call it 1, 5, 10 or whatsoever? Or do we call it infinity? It's a complex thing, right? Now, how do we do this? There is a method to this. Let us see. Firstly, if we try to one option is if we try to draw this graph of sine theta by theta, it will look something like this. So, for example, uh, forget about zero when it is zero. When it is not zero, how does it look? When it is sine pi by pi, this is zero. Sin pi by two by it is zero. Sine three pi by pi, it is again 0 because for all those cases, um, sine pi, sine 2 pi, sine 3 pi are zeros. At the same time, when it is coming closer to 0, for example, like this, line coming closer to 0, for example, if we talk something like sine pi by 2, sine pi by 2 by uh, pi by 2, if we are talking about sine pi by 2 is 1 by pi by 2. So 2 by pi, something like this. Okay, some value is 2 by pi. It is actually increasing. So if you try to uh, calculate this sine theta by theta for multiple values using a calculator, you will get a graph like this. You'll get a graph like this. If you try to do this calculations, right? Sine pi by 2, sine pi by 4, or whatsoever, sine pi by 10. If you try to plot all the calculations, then you will get some graph like this. Okay. Then it looks like in the graph, this value when theta is approaching 0 is approaching 1, both from the left side and the right side. Firstly, sine theta by theta, this is an even function. Sine theta is odd function. Theta is also odd function, right? So odd by odd, it is even, right? Because sine of minus theta by minus theta, right? This becomes minus sine theta by minus theta, which is equal to minus theta, which is equal to sine theta by theta, right? Which is equal to sine theta by theta. So if we if we call this f of theta, then this function is actually even function. What does that mean? Whatever is on the right hand side, the graph of this, the left hand side also will have the same graph, right? If we try to plot some values on the right hand side, we can automatically extend that to the left hand side because this is an even function that should be symmetric with respect to y-axis, right? Because both are odd functions. Sine of minus theta by minus theta, it will become sine theta by theta. So far so good. By plotting this, it is looking like it is approaching 1. But this is not a sufficient proof, right? The mathematicians, they don't accept this kind of proof. We need a more rigorous proof. Okay, so to understand what is the proof, first we will understand what is this sandwich theorem. There is a beautiful sandwich theorem, very intuitive theorem. What does this theorem say? Let's say there are three functions: g of x less than or equal to f of x less than or equal to h of x for all x in some open interval containing c. There is some c, and within this open interval of this c, within this c, some within the range of this c, open interval could be from here to here or from here to here, whatever. Within this range, except possibly at x equal to c. At this point, we may don't need to know, but for all the other points, if this function is lower less than or equal to this less than or equal to this, we don't need to know the exact values. Overall, this one should be in between this and this and this. And at the same time, limit extends to c g of x, that is the lower one, is equal to limit extends to c h of x. If this is equal to l, for example, the lower one is approaching a limit, the upper one is also approaching the limit, then what that means is the middle one will also approach the same limit. Very intuitive. It looks very fine, right? We all readily agree to this. Please note here we are not talking about g of c, right? Or we are not talking about h of c. We are not talking about f of c. We are talking about limit extends to c f of x, right? Or limit extends to c g of x. This is a very intuitive theorem, right? We can agree to this in a very easy way. Now let us use this here, use this theorem. Okay, and try to prove and try to find out sine theta by theta limit x theta tends to 0 is actually 1. Okay, let us take a circle here. Let us take a circle which is of unit radius. Unit radius means radius is 1. So obviously this from here to here, it is length 1. From here to here, it is length 1. Let us take this point A 1 0. This is x-axis, right? And this is y-axis. Let us take this point A0 and let us draw one random triangle. Okay, OAP. Let us draw a random triangle. Okay, obviously OP, this is the radius, the length will be 1. Let's assume this OP is making an angle theta with respect to the x-axis. Then now, what is the coordinates of this P? This will be cos theta, sin theta, right? Cos theta, because the radius is 1, r cos theta and r sin theta, right? Radius is 1, basically sin theta and cos theta, right? This will be cos theta and this will be sin theta. Basically, sin theta is opposite side by sin theta is opposite side by hypotenuse, and hypotenuse is 1. Okay, hypotenuse is 1. So obviously opposite side should be equal to sin theta. Similarly, cos theta is adjacent side by 1. So adjacent side by hypotenuse is anyway 1. So that's why this should be cos theta. Right. Now this length PQ is sin theta and OQ is cos theta. Okay. This is a triangle. Let's do one more thing. This OP let us extend to this T and draw a perpendicular from this T to A. Basically draw a perpendicular at A and let it make this extension OP at some T. Okay. Now let us carefully watch. We have OAP, this triangle. Sorry, OAP, this triangle. Okay. Let us watch this triangle. This is one triangle. Okay. What is the area of this triangle? Half base into height. Half into sine theta into 1. Okay. Half into 1 into sine theta. This is area of this triangle. Okay. Half base into height. Now let us take this sector. OAP again. This sector. This sector. What is this sector? This is the sector, right? Now, what is the radius or what is the area of the sector? We know area of a circle is pi r square, right? And here we are talking about radians. So 2 pi radians, for 2 pi radians, for 2 pi radians, entire circle is 2 pi radians. What is the radius? What is the area? Pi r square. R is anywhere 1. Right, for 2 pi radians, it is pi. Area is pi. Now for theta radians, how much it will be? For 2 pi radians, the radius is pi r square, which is equal to pi. For theta radians, what it will be? Theta by 2 pi into pi. Pi and pi will get cancelled, theta by 2. Basically, the area of OAP, this sector, is equal to theta by 2. Right. So please note, we are talking in terms of radians. 2 pi radians, the area of a circle is pi r square. Here radius is 1, so that's why 2 pi radians, the angle is, entire angle is 2 pi, then area is pi. And if the angle is theta, then theta by 2 pi into pi, so it is pi by 2, this sector. Okay. And what about the bigger one? Bigger one, this is again a right angle triangle, OAT. This is again a right angle triangle, and this angle is theta. Obviously, this angle is, and this length is 1. Obviously, this will become tan theta, right? Tan theta is opposite side by adjacent side. Now, adjacent side is equal to 1, so opposite side should be equal to tan theta. So, what is the area of OAT? Half into base into height, half into 1 into tan theta, half tan theta, right? Now, we can clearly see this triangle OAP. This triangle area is lesser than this triangle this sector OAP, right? Obviously, because this part is high. more in this sector, right? This part is more in the sector. So this triangle is lesser than sector, then again bigger triangle. This triangle, right? This big triangle, it will include this part also. Okay, OAT. So basically what we are saying, OAP, OAP triangle, OAP sector, and OAT triangle again. Okay, the areas are half sine theta is less than half theta is less than half tan theta. Okay, basically what we are trying to say, sine theta, sine theta is this length of the height of this triangle. What we are trying to say, this one will always be lesser than this one because this is a hypotenuse. This is a hypotenuse. PA is this length, this height will always be lesser than PA, and PA will always be obviously lesser than the length of this curve because this is the straight line would always be lesser than the distance um, of any curve or any distance covered by joining by any other means. If it is not a straight line would be the smallest. Okay, we are trying to say this basically. Okay, now we have got this. What does that mean? If we divide everything by 1/2 sine theta, or we cancel half and divide everything by sine theta, 1 less than theta by sine theta less than 1 by cos theta, right? Tan theta, tan theta is sine theta by cos theta. You divide it by sine theta, so sine theta will get cancelled. So it will become 1 by cos theta. Please note, when we are dividing, obviously sine theta has to be positive. Otherwise, we cannot say this, right? So, for example, if we say minus 3 is less than 1 less than 4, we cannot divide by minus 3 and say you cannot divide it by minus 3 again and say 3 is less than minus 1 by 3, right? For example, if we divide it by minus 3, then obviously the less than sign will change, right? So obviously when we are dividing and if you want to maintain the same inequality, we have to ensure that this is positive. And because we are talking about theta which is lesser than 90 degrees here, so it is positive. Okay. Now, we'll let us just reverse this. Reverse this. 1 by 1 is anyway 1. If we reverse this, obviously the signs will change. It becomes 1 greater than sine theta by theta greater than cos theta. Okay. So we have found another inequality. Now, let us use our sandwich theorem. Okay. So cos theta, when theta is tending to 0, it is equal to 1. Theta is tending to 0 from the positive side. Okay. Because so far we are concerned about theta which is positive only. Okay. Then, when theta is tending to 0 from the positive side, cos theta is equal to 1. Basically, 1 greater than sine theta by theta is greater than 1. So that means we are somewhere like this, right? This is sine theta by theta, this is cos theta, and this is 1. Okay. So what does that mean? Limit theta tends to 0 plus. 0 plus, this should be equal to 1 because this is limit of cos theta is 1 and limit of 1 is anyway 1. This should be equal to 1. But here we are concerned about, so far we are talking about theta plus. That is, theta is positive and we are approaching theta from the positive side. That means theta is reducing and becoming 0. That is fine. Now, we already discussed that sine theta by theta is an even function. What that means, whatever we have discussed so far, the same of it will apply from the left hand side also. Here we are talked about this one. Right hand side, if we are approaching, then this is approaching the 1. Left hand side also same thing will happen because this is an even function. So net we can say that's why this left hand limit theta minus 0 minus is also 1. Okay, now left hand limit is also 1, right hand limit is also 1. We can call it 1. Okay, very simply what we are saying, theta by sine theta by theta is equal to 1. What does that mean? When theta is becoming smaller and smaller. Okay. What is sine theta? Sine theta is this length. Okay. This length will become closer to this length, this curve, which is also natural, right? As this becomes smaller and smaller, this one would be closer to this one, right? For example, if it is like this, compare this length versus this length, this entire arc length. This entire arc length is much bigger. But as theta becomes smaller and smaller, smaller and smaller, this line and this curve will become closer. This line and this curve. When theta becomes smaller, the line will become shorter and the curve will also become more like a straight line. Right. Intuitively, what we are trying to say, as theta becomes very, very small, this line, which is sine theta, right? This line becomes small. At the same time, when at a small angle, this curve will also be like a straight line, right? Very small angle, very small angle, very small angle if we take, then this part of the curve is almost a straight line. The curve will look like a curve as we increase the angle. So from here to here, if you see, it's a big curve. But if you see from here to here, then it is like a straight line. Or from here to here, it is like a straight line. If you take very small part of the curve, it is actually a straight line. Right. It resembles a straight line. So intuitively we can see that when theta is very small, when theta is approaching zero, right? It is approaching zero. Then the value of sine theta and the distance of the curve and the value of this r will become very close. That's why sine theta by theta is this limit actually approaches 1. This is an intuitive understanding also. But this is a mathematical proof how to showing by areas of different triangles and using left hand side limit and right hand side limit. This is a very important result. We use it at multiple places. Right, let's take one very, very small example. Let's say sine 2x by sine 5x. Here we know x tends to 0, but we know limit theta tends to 0, sine theta by theta. We want sine theta by theta format. Here it is not theta by theta. It is like 2x by 5x. If this was 2x and this was also 2x, then we would have directly applied. Now what we do? We'll just multiply with 2 by 5 on the numerator and denominator. Why we are doing this? Because we want to cancel these 5's and we want 2x in the denominator. Okay, so we'll take this 2 by 5 out, limit x tends to 0, sine 2x by this 2x. Right. Now, when x tends to 0, obviously 2x also will tend to 0. We can write this as limit theta tends to 0, sine theta by theta, where theta is, what is theta? Theta is 2x. We can write this as. Otherwise, you don't even need to write. It is understood because x tends to 0. That means 2x also tends to 0. So limit of this part will be equal to 1. So 2 by 5 into 1 is equal to 2 by 5. Okay. This is a very simple application. And we use this result, sine theta by theta, limit sine theta by theta at multiple places throughout limits. Right? This is a very, very important result. And it is very important to understand the proof of this result and appreciate the beauty of this result and understand intuitively why this is true. Right, guys? Hope you like this. Thank you.